In this lesson, we will answer what is data mining and equally importantly, what it is not. And we'll see where data mining fit in the continuum of analytics. Data mining is the key enabler of analytics. It's in the heart of analytics continuum. As you can see in this taxonomy that we talked about, data mining and its variants, text mining, web mining, multimedia mining, are the enablers of predictive analytics, but it also provides significant contribution to both descriptive, which we're going to talk about, as well as provide the knowledge, information, and content that leads to prescriptive analytics. Data mining is also called predictive analytics, all by itself, because a lot of the patterns in data mining is predictive in nature as opposed to descriptive. That's why a lot of people prefer to call it predictive analytics, and that term has become quite popular in the last 4 or 5 years. There are conferences around predictive analytics where they talk about data mining methods and algorithms. Data mining has many definitions, and definitions have changed and is still changing in content and in coverage. There is narrow definition of it that is very algorithmically, specifically predictive focused, and there is broad definition of it which in most cases is not even accurate because anything and everything that has to do with data and searching is named as data mining. But at the end, data mining is the discovery of knowledge from large collections of data. It supports evidence-based management. Evidence here is the data, is the transactions that happened and collected by the organization in a historical fashion, and then you can dig in and find those correlations, those patterns, those relationships that you have never thought about and can act on. And that is what data mining is. That is what data mining actually supports. So data mining is the, again, enabler of this data to information, information to knowledge continuum. So data all by itself is collection of facts. Doesn't mean anything. It has to be contextualized. It has to be summarized so that it would bring out meaning as to what the data is representing, what happened, using mostly descriptive analytics techniques. And then the data and information collectively can be used and contextualized in data mining algorithms, help of data mining algorithms to turn it into knowledge, turn it into actionable insight, turn it into new patterns, new best practices that have not been known or discovered previously but can be acted on for business purposes. The next layer beyond knowledge is nowadays called wisdom. Wisdom is a state of mind where the knowledge can be created without explicitly crafting it, designing it, and creating it. People who have the wisdom, we call them gurus. They have the means and capability of extracting new knowledge from the knowledge and experience that they already have without tapping into and explicitly programming, crafting, and processing the data and information. There are centers that are funded with millions of dollars to define what wisdom is. It is difficult to define, it's difficult to conceptualize, but it is something that's beyond just knowledge at a level of intelligence that only a few can reach. So why data mining is popular? These popularity points are somewhat resembling to the popularity points of analytics. At the end of the day, in a business context, it's all about making better business sense in this global competition environment where the profit margins are reduced, but the volumes are increased. So if you do what you need to do in an efficient and effective manner, you can generate significant profits. To be able to do that, you need to use data mining. You need to do all that's available to you in the data and algorithmic sense to make evidence-based, rational, and creative decisions. Customer needs are changing, the profiles are changing, their wants are changing, and you need to be proactive to mine into the data, both structured and unstructured, to figure out what those needs and wants are so that you can meet them before your competitors do. Recognition of data as an invaluable asset is also bringing a positive input to the popularity of data mining, changing culture and management style. Data has become the asset of organization. People now know that they can actually extract actionable insight from data, and that's changing the way that the management treating and utilizing data in the context of data mining. There's better and improved automated ways to capture and store the data. It's cost effective, it's faster than it has ever been. So we have the means to actually obtain the data, to integrate data, to store data, and then extract those actionable insight and knowledge out of data using data mining. Not to mention all the hardware and software algorithms and tools are becoming widely and readily, and in most cases freely available to commercial companies, for-profit companies, non-profit companies to tap into their data sources and extract information to act on them. So there is so much motivation behind data mining and its popularity that's pushing it forward and making it a core enabler of the analytics continuum. So what is really data mining? It is the process, multi-step, recursive, iterative process of discovering, quote-unquote, mining knowledge, actionable insight from large amounts of data. It could be large, it could be small, but a lot of definition of data mining requires data to be characterized as large enough so that you can find undiscovered patterns and knowledge nuggets to act on. Is data mining a misnomer? Is it an inaccurate naming of what it actually means? It probably is, because the things that we call mining, like coal mining or gold mining or gem mining, the thing that we mine for comes before the word mining. In this case, data mining, we're not mining for data, we're mining for knowledge, we're mining for insight, patterns. So it probably would have been better served to be named as knowledge mining, pattern mining, or knowledge discovery, but it has not been. So we will go with the name data mining because that's stick, even though people suggested other names like knowledge discovery, information extraction, pattern analysis, information harvesting, pattern searching, and many others. But the name that stick and name that everybody is using is data mining. Here is an official definition of data mining coming from 1996. Some of the gurus who coined the name data mining defined it as the non-trivial process of identifying valid, novel, potentially useful, and ultimately understandable patterns in data stored in structured databases. So there's a lot of keywords here that we need to look at. One is process. It's a process, it's a non-trivial process that needs to be structured, driven from best practices, a multi-step, iterative, recursive process that will lead you from data into actionable insight. Valid, the pattern has to be valid. It has to have the means to be validated. It has to be novel, new, something that you have not done or discovered before. And it has to have some kind of usefulness, some kind of value for that pattern to be called data mining pattern. And it should be ultimately understandable. Even though it's new, once you find it, you come up with this aha moment that says, why didn't I think about that? It makes a lot of sense now that the data mining algorithms found it for me. I can act on it. I can benefit from it. So data mining is not a discipline by itself. It is a philosophy, if you will, that sits in between many different disciplines and takes advantage of their capabilities. The disciplines that it leverages includes statistics, a little. So data mining is not really statistics, but it does consume good portion of statistics. A lot of the artificial intelligence, machine learning, pattern recognition type of algorithms makes a big portion of algorithmic extent of data mining. Information visualization, graphical depiction, and illustration of the knowledge and the patterns. Data management, data warehousing plays a significant input into data mining and kind of lays the foundation for data mining algorithms and methods. Also, management science systems, the scientific extent of information and data also becomes a pillar that supports data mining activities. Data mining has multiple variations, different names. One of which is called text mining. It's basically data mining where the data is in textual form, which we're going to talk about and in detail cover in one of the future lessons. Web mining, mining the content captured, represented on the web. Either it's the content, the structure, or the usage patterns, clickstream, if you will, data that can be used to extract knowledge. And we call it web mining. It's a variant of data mining. Multimedia, not only data in the textual or numeric form, but also the voice, the image, the video can also be mined. And that's another variant of text mining. Social media mining is probably a conceptualization of both structured and unstructured data presented on social media and social platforms that can be mined for actionable insights. So data mining to me is the overarching terms. Within that, we have text mining, web mining, multimedia mining, as well as social media mining. Now, equally important, what data mining is not, because people call data mining everything. Everything that has to do with data, search, or finding is called data mining. It really is not. For instance, data mining is not an internet search. So if you're browsing for information on the web, you're not really doing data mining. What you're doing is called information extraction, finding relevant pieces of information in different websites, and then you're going to probably do the mining in your mind to kind of synthesize what you found to actually turn it into actionable information. So web crawling, internet search, they are not data mining. OLAP stands for Online Analytic Processing. It's the foundation of business intelligence. It looks at the data and it cross-tabulates and graphically illustrates data captured in structured databases such as data warehouse. And that is not really data mining. That is business intelligence. That is descriptive analytics, but it is not really data mining. And statistics by themselves is not data mining. Data mining and statistics is not synonymous words. Data mining uses a lot of the statistical methods, but it goes way beyond statistics and taps into artificial intelligence, machine learning techniques, neural networks, decision trees, and what have you, which is an extension, in some case, contradiction to some of the statistical methods. So data mining uses more of the modern day of information processing in the AI sense than it does use statistics. Data mining at the end of the day is the discovery of knowledge. It's, again, going back to the definition, it's a non-trivial process of tapping into data, finding something new, useful, and novel, and then using it in a business context or a social context to make faster, better, more informed, more evidence-driven decisions.